Okay, so why I put these in a separate section in the textbook is this. They're a little bit different. We're not finding a center point in just the intercepts. The center point is the asymptotes. So we need to find what we would call the vertical and horizontal asymptotes. So what is an asymptote? Anyone know? Or can guess? And you know I like you to be wrong, so any guess is okay. Okay, there is a wrong answer I'm looking for. Who can guess what the wrong answer is? What's an asymptote? You did them in high school. No one has a guess? Okay, so it's a dotted line on a graph. Why is it dotted? Let's draw an asymptote. All right, so it's a horizontal line in this case. So is that y equals or x equals? Think your basic graphs. Y equals. So this would be the line y equals 2. We put it dotted because it's not really part of the graph. It's sort of like a brick wall. Why is it like a brick wall? I see people whispering now, so maybe you're getting the idea. I want someone to say it's a line that you can't cross. Does anyone agree with that? It's not actually true. And that's why I wanted someone to say it, to tell you, you can. There are lots of cases in the world that you can cross a horizontal asymptote, okay? There's a graph that looks like, I'm not going to give you the equation of the graph, but there's a graph that looks like this. You'll see it when you do calculus. So that actually crossed through the center. So an asymptote is not a line that you can't cross. But what it's actually telling us is the behavior out here at the ends. Remember when I talked about 1 over x as a graph? This is the only one we're doing in this class. I said this is like a skateboard ramp. And I said what happens is we've got the ground, and our skateboard ramp comes close to it at the end, but it can't ever get into the ground. Right, it lays on top of it, so it's getting closer and closer. And you could make the ramp really, really thin at the end so it looked like it was part of the ground, but it's still on top of the ground. Okay? So it is separate, but it gets close to that. So this graph at the ends is getting close to y equals 2, but it's never actually touching y equals 2. But that's only the behavior at the ends. Okay? It doesn't talk anything about the behavior in the middle. So you can cross an asymptote somewhere else, but not at the ends. That's the idea. Okay? So what do you think these lines are on this graph? So this is the line y equals 0, and this is the line x equals 0. They are what don't work in the graph. So 1 over 0 doesn't work. Do you agree? We can't plug in 0 because that would make us divide by 0. So the vertical asymptote are found by finding the restrictions. We did that before. You'll get a slightly different view of this in calculus, but the idea is the exact same. When you see this again in calculus, they'll define it a little bit different, but it's the same thing. Remember when we have a rational equation or function and we simplify it, sometimes we cross off some of those restrictions, then we list them at the end. as part of the domain, but they're gone, you don't see them anymore. Those are not vertical asymptotes. The ones that are vertical asymptotes are the ones that are still there at the end. Does that make sense? So that's what I wrote here. They're found by finding the restrictions that don't cancel when you're simplifying. Sometimes we cross off restrictions that cancel. We kept track of them, but those are not the vertical asymptotes. They're actually just a hole in the graph. We're not going to see those in this class, but that's what they are. If they cancel, they're a hole in the graph. If they're still there at the end, they're an asymptote. Okay. And we're only going to see simplified ones, and that's what I'm saying. The definition doesn't matter, but you'll see it more because you'll get more complicated ones when you do calculus. So in our example, or any example that we do, we're going to have a number on top and a linear expression on the bottom, say 2x plus 3. So we're only going to see this type with a constant on top in the numerator, and a linear denominator. So of course there's many, many, many kinds, but you need calculus to draw most of the other ones. That one I drew up here, you'll learn how to draw that from the equation in calculus, but it involves derivatives, and we're not doing that, of course, so we're just sticking to the ones we can do without any simplification. Okay? So they're actually not going to be hard in our case. Okay? So this, what would be the vertical asymptote of this particular equation? That is where 2x plus 3 equals 0. So that's our vertical asymptote. Okay? Now, we'll draw that in a minute, but we won't do that one quite yet, just the vertical asymptote. Now, the horizontal asymptote, I'm not giving you the actual definition because you need calculus to find it, but we're going to cheat, and I'll show you how to find it with our particular equations only. Okay? So we're just going to do these easy ones. So the horizontal asymptote in our equations is found by, I don't even like doing this, but that. Okay, because there's way more to it than that, but you need calculus to find it. Okay, so we're not going to do the calculus part of it. We're just going to say whatever number is added or subtracted at the end is the horizontal asymptote, and we'll keep it simple like that. So y equals 2 is the horizontal asymptote, and x equals, what's the vertical? -3. It's wherever, whatever number we can't plug in, that'll make 0 in the denominator. So -3 is the vertical asymptote. So that's as hard as we get with our particular examples. Okay, so I'll just write this on the next page and we'll draw it, because that's all you need to know. Those are the centers, and you know what the basic graph looks like. So you draw the asymptotes first. So x equals 3 is -3 is a vertical, so it goes through. If you go and put -3 for your x, it has to go through that point. X equals -3, that's a vertical line. Y equals 2, don't get them mixed up. That happens a lot on tests. What's our basic graph? Like that? Okay. So they're in, this is the positive quadrant, and this is the one opposite. Okay? Now what you're looking at when you look at your new graph is my pink dotted lines are these. Okay? So you ignore the green, and you draw the graph here and here. That's, yeah, exactly. This point right here is your new origin. right? The new 0, 0, and you draw it. Do you see it? That's right. Now, we did cross the axis, and we have to find both of them, which we totally know how to do because we spent so much time solving these equations. There's nothing new there. So let's do it. So our y-intercept, do we have a y-intercept? Yeah, right up there. And where's our x-intercept? Right down here. So y-intercept, let x equal 0. Zero plus 3. It's 1 over 3 plus 2. How would we solve that? Common denominator. So we're going to multiply that by 3. So 7 over 3. So we have a point, 0, 7 over 3. That's 2 1/3. All right, 2 3s go into 7 is 6 and 1/3, which makes sense. It's bigger than 2. So 7 over 3, 0, 7 over 3. And now this one, our x-intercept, we let y equal 0. It's a little harder, but there's nothing new. You already mastered this. And they're always the same solving because we're not getting more complicated ones. So they're actually easier than anything we've done. How do we solve this one? No, I wouldn't do common denominator. Move the 2 over or the fraction over, and then you can cross multiply. Remember, if there's one term on each side of the equal signs, you can cross multiply. So I'd move the 2 over. So minus 2x minus 6 minus 2x equals 1 plus 6. X is 7 over minus 2. And does that make sense that that would be the point? 7 divided by 2 is 3.5, and that's negative 3, so this makes sense that that would be 3.5. Okay. Now, how would we flip these ones? What would the graph look like if we were to flip it? Yeah, so what would happen is if we had, like, say, negative 5 over x plus 1, something like that. So I've changed the fraction part to a negative. Where would it look like? Here's our basic graph. That's 1 over x. Negative 1 over x will be what? Here and here, right. And of course you can plot a few points to be sure you're in the right quadrants if you're unsure where it would be. So really anywhere in here. We'll just plot this quickly. What's the vertical asymptote? Vertical is what makes the fraction not work. That's the x value that doesn't work. So what's the x value? What can we not plug into the denominator here? Negative 1. So x equals negative 1. The horizontal asymptote, it's right here, 2. X is negative 1. Y is 2. And where will this one be? So it's going to be the negative. So you're ignoring the regular axis and you're looking at your new axis. We want it to be in these two quadrants, here and here. This is the one that crosses both axes. So when you find your 2 points, they'll actually be on this part. Don't forget to draw the other part, though. They're always across from each other.
So you don't need
No, you can just write them in after, and that's what I said. It's better to draw the basic graph in the right position first, and then just tweak it if you need to. Right, like what if I find that the x and y intercept is 0, 0, then I would get this graph marked wrong, because I'm not going through 0, 0. Do you see that? It is not going through 0, 0, so that would be wrong. What we would get, just without plugging them in, I'll just give you the answers. So this would be 0, negative 3. So 0, negative 3 is where? Down here. So I would have this marked wrong if I didn't fix it. Right, if I plug x is 0 in here, I get what? Negative 5 over 0 plus 1 plus 2, negative 5 plus 2, negative 3, 0, negative 3. That's down here. So even though I drew the basic graph, it's not in the right spot until you find your intercepts and make sure. So where does it go? It's probably more likely like this, and then we still need to find that point. Right, but you need to fix it up after you draw it. So you draw your basic graph in, at least get in the right spot, in the right shape, find your intercepts, and then just tweak it. And that's what I said, that's why I was using the pipe cleaner earlier in case I drew it in the wrong spot. So I could just move it without having to erase it. So the green, and this one would mirror that, so it would actually be a little bit further away from the center. That 5 is what makes it further away. Yeah, you could find them. The reason I don't like you to find the intercepts first is because sometimes we don't have them, and if you see what the basic graph looks like, not for these, they're going to cross, but for some of them they won't cross, and then you've done a whole bunch of work for nothing because you didn't even need to find them. So if you draw your basic graph in first. Okay, so practice these.